Friends, in today's tutorial, we are going to talk about derivatives by using chain rule. In my earlier video, I had given you detailed explanation to solve the derivative problem by using first principle. This video is exclusively for differentiation by chain rule. Before proceeding further, I request you that do the problems along with me in your notebook, then only you will have the perfect understanding. Whenever you do the mathematics, we become master of mathematics only when you do the problems with your own hands. Even though I do the 1,000 problems for you, but if you are not doing with your own hand, you will not become the master. You will able to do only the few problems, but if a new problem is given, you won't be able to solve. If you wish to solve a new problem on your own, then you must do the problems in your notebook along with me. Here, I am going to solve the ample of problems on derivatives by using the chain rule. Under what condition you use chain rule of differentiation? So the condition is the given function must be a composite function. When it is a composite function, then only we can do chain rule. We can use chain rule. Otherwise, if it is a standard function, we can directly find out derivative. Example, y equals to x raised to 5. This is directly a standard function. For that, we need not use chain rule. Example, dy by dx equals to derivative of x raised to 5 with respect to x equals to 5x raised to 4. Here we can do directly because the given example was not a y equals to x raised to 5 is not a composite function. It is a direct. It is a standard function. For the standard function, we don't use chain rule. But to use a chain rule, the function must be a composite function. That is y equals to ax plus b raised to 5. Now this is not a standard function. It is a composite function. In case of composite function, you use chain rule of differentiation. And when a composite function is given, we directly cannot obtain the dy by dx. For that, we have to convert into composite function. Example, let ax plus b equals to u. Then it becomes y equals to u raised to 5. Now you see that y depends upon u and u depends upon x. In such case, we need to apply chain rule. Now suppose you wish to find out dy by dx, then what will you do? Dy by dx equals to dy by du and du by dx. We use this idea to find out dy by dx. And this idea is nothing but called chain rule. Let us do some problems on chain rule for better understanding. First example, y equals to 2x plus 3 raised to 5 and find dy by dx by using chain rule. Now, step 1, it is not a standard function. To convert into the standard function, first of all, we write the given problem as it is. Y equals to 2x plus 3 raised to 5. Let u equals to 2x plus 3. Therefore, y equals to u raised to 5. Because we assume 2x plus 3, in place of 2x plus 3, we can write u. Therefore, y equals to u raised to 5. Now it has converted into standard function. Now only two variables are there. One is the y, another is the u. So here differentiating both sides with respect to u. Then dy by du. We write u here, and here the derivative or differentiation of. When you speak of, write down the bracket, and in the bracket you write down the given question, that is u raised to 5 with respect to. While speaking u with respect to, write down this line with respect to u. Then derivative of u raised to 5. Derivative of u raised to 5 nothing but 5 u 5 minus 1. I want to recall for you differentiation of x raised to n with respect to x equals to nx raised to n minus 1. Therefore, derivative of u raised to 5 nothing but 5 u raised to 5 minus 1, that is equals to 5 u raised to 4. This is dy by du, and let us call it as a equation number 1. After that, but u equals to, what is u? U is nothing but 2x plus 3. So now u depends upon x. Here y equals to u raised to 5. Then y depending upon u. Therefore we done dy by du in case number 1. But now u equals to 2x plus 3. So u is depending upon x. So what you do? You do differentiating both sides with respect to x. So we write du by dx equals to differentiation of 2x plus 3 with respect to x. Derivative of 2x is 2, and derivative of 3, it is the 3 is a constant. Therefore derivative of 3 equals to 0, that is 2 plus 0, that is equals to 2. Here derivative of 2x, derivative of 2x is 2, derivative of 3x is 3, derivative of 4x is 4, derivative of nx is n. You remember this one. Now, so du by dx equals to 2. Now you need to find out dy by dx, that is our ultimate aim. So dy by dx nothing but dy by du and du by dx. This is nothing but chain rule of derivative. So we are having dy by du nothing but 5 u raised to 4, and du by dx is nothing but 2, that is equals to 5 into 2 into u raised to 4, 10 u raised to 4. What is u? U nothing but 2x plus 3. So you write here the 2x plus 3 raised to 4. Therefore the differentiation of 2x plus 3 raised to 5 with respect to x nothing but 10 2x plus 3 raised to 4. This is ultimate result. Thus in chain rule, what you do? First convert the given function into standard form, then you do the derivative 2 times. First dy by du, and the second time you do du by dx, then you multiply both the results. Let us take one more example. Next example, y equals to under root of 6x plus 5. What is inside the root? Whatever it may be, not only algebra. I will take more example, under root of sin x, under root of tan x, like that. In root any function may be there. We don't bother about that. So first of all, we write here y equals to root of 6x plus 5. Suppose only root x is there, then I will give you one formula. Whenever the root x is coming, what is the derivative of the root x? So I am going to give you one shortcut idea to how to remember the derivative of the root x. So here I am having the root x. So root x can be written as In place of the root, you can write x raised to 1 by 2 power x raised to 1 by 2. Derivative of x raised to 1 by 2 is nothing but 1 upon 2 x raised to 1 by 2 minus 1, 1 upon 2 x raised to 1 minus 2 upon 2, 1 upon 2 x raised to minus 1 by 2 equals to 1 upon 2 root x. That means I am giving you one formula. Derivative of root x with respect to x equals to 1 upon 2 root x. If you remember this formula, then your job becomes easy. So repeat once again. What is the formula for root x? Differentiation of root x equals to 1 upon 2 root x. One more time please. Differentiation of root x equals to 1 upon 2 root x. So what I do here, let u equals to 6 plus 5. Therefore y equals to root u. Now differentiating, what is the step 1? Step 1 is a dy by du and second step is a du by dx. So differentiating both sides with respect to u. So what you get here? Dy by du equals to differentiation of root u with respect to x. Now with respect to u, not x, sorry. So differentiation of root u with respect to u. Now what is the answer for root x? The answer for root x is 2 root x, 1 upon 2 root x. Derivative of root x equals to 1 upon 2 root x. Therefore derivative of root u with respect to u equals to 1 upon 2 root u. That is dy by du. Let us call it as a equation number 1. After that, but u equals to 6x plus 5. What you do? You see, whenever the given problem, step number 1, supposition u equals to, that is the step number 1. You remember it. In the chain rule, this step is valid for every problem. In the second step, dy by du equals to, we get here, call it as equation number 1. After that, you remember that, but u equals to 6x plus 5. You remember this stage. And after you are writing u here, what you do? Differentiating both sides with respect to x. What you have to write down? Differentiating both sides with respect to x. So du by dx equals to differentiation of 6x plus 5 with respect to x. Now differentiation of 6x is 6 and differentiation of 5 is 0. Therefore du by dx equals to 6. Call it as a equation 2. Now I said you in chain rule, first you get the dy by du, in the second step you get the du by dx. Now you have to multiply both of them. So what is the chain rule formula? Dy by dx equals to dy by du into du by dx. You multiply both the results. What is the result number 1? 1 upon 2 root u. And what is the second result? 6. So that is 6 upon 2 root u. Now what you do now? Here if cancellation possible, you cut down, no problem. 2 1s are 2 3s are cut down. So we get dy by dx equals to 3 upon root u. So 3 upon, what is u equals to? U equals to 6x plus 5. Therefore 3 upon 6x plus 5. Therefore the final result, how to write the final result? Therefore differentiation of root 6x plus 5 with respect to x equals to 3 upon under root of 6x plus 5. This is the result. This way we perform the chain rule. Now let us do one more example. Next example, suppose y equals to root of sin x. It is equally valid for every other trigonometric function. In place of sin x, there can be cos x, tan x, sec x, cosec x, anything. So let us do this first problem in detail. Then second problem, we will do shortcut. So first of all, y is equal to root sin x. Then step number 1, let sin x equals to u. Then we get y equals to root u. Now differentiating both side with respect to u. Therefore, dy by du equals to differentiation of root u with respect to u. That is equals to 1 upon 2 root u. That is dy by du equals to 1 upon 2 root u. That is equation number 1. Actually, dy by du we don't speak. We have to speak differentiation of y with respect to u. We have to speak such a big sentence. So, you see, I am a little bit lazy. So, how to speak dy by du? Okay, but step number 2, but u equals to sin x. Therefore, now here u equals to sin x. Here is the RHS is sin x. U is the function of x. Therefore, differentiating with respect to x, both side. So we get du by dx equals to differentiation of sin x with respect to x. That is equals to cos x. So du by dx equals to cos x. Let us call it as a equation number 2. Now, according to chain rule, dy by dx is nothing but multiplication of step 1 and step 2. Step 1 is dy by du and step 2 is du by dx. You need to multiply both of them. So dy by du is nothing but 1 upon 2 root u and du by dx is nothing but cos x. Now what you do now? You put back the values. Dy by dx equals to cos x upon 2 root u. What is u? U is nothing but sin x. You have to put back the value of u. If you keep u as it is, then it is not allowed. You have to at the end, what is u? U equals to sin x. You have to put back here. So dy by dx equals to cos x upon 2 root sin x. How to write that? Therefore, differentiation of root sin x with respect to x equals to cos x upon 2 root sin x. This is answer. You see, in place of sin x, there can be cos x, there can be tan x, there can be cot x, any other trigonometric functions. Then we do derivative similar way. Let us have a look. Let us take one example and understand how will you handle other trigonometric functions. Let us have another example, y equals to under root of cos x. So let cos x equals to u, then it becomes y equals to under root of u, then differentiating both sides with respect to u, then dy by du equals to differentiation of root u with respect to u equals to 1 upon 2 root u, that is dy by du. Call it as equation number 1. And after that, but you remember this, but is a turning point that comes after the step 1. U equals to cos x, then differentiating both sides with respect to x, then du by dx equals to differentiation of cos x with respect to x equals to minus sin x. Then call it as equation number 2. After that, dy by dx equals to dy by du into du by dx. What is dy by du? 1 upon 2 root u, and du by dx nothing but minus sin x. So So that is equals to dy by dx equals to minus sine x upon 2 root u. So dy by dx equals to minus sine x, and what is u? U is nothing but cos x. So here the cos x will come, and how to finally write? Finally we can write differentiation of root cos x, under root of cos x with respect to x equals to minus sin x upon 2 root under root of cos x minus sin x upon 2 into under root of cos x. So this is the answer. Let us have one more example. Next example, y equals to under root of tan x. Step number 1, let u equals to tan x, then y equals to under root of u dy by du equals to derivative of root u with respect to u equals to 1 upon 2 root u dy by du. Here I am doing little fast and skipping some steps as well as. I hope you are getting through. But u equals to tan x du by dx, differentiating both sides with respect to x, du by dx, that is derivative of tan x with respect to x equals to sec square x. Now dy by dx equals to dy by du into du by dx. I corrected the equation 1 here, and equation 2. dy by du nothing but 1 upon 2 root u, and du by dx is nothing but sec square x. So dy by dx equals to sec square x upon what is u? U is nothing but tan x. Therefore sec square x upon 2 into under root of tan x. This is the result. Therefore differentiation of tan x with respect to x equals to sec square x upon 2 root tan x. This is answer. Sec square x upon 2 into under root of tan x. That is, once again, differentiation of root tan x with respect to x equals to sec square x upon 2 into under root of tan x. Next example, y equals to under root of cot x. Now one should know derivative of cot x with respect to x, nothing but minus cosec square x. Now we do it as earlier, only the function has changed. In place of tan x, the cot x has come. So cot x nothing but u. So that is the under root of u. Then dy by du equals to 1 upon 2 root u, and u equals to cot x, and du by dx equals to minus cosec square x. This becomes equation 1 and 2. Multiply both the results. dy by dx equals to dy by du into du by dx. So dy by du nothing but 1 upon 2 root u and minus cosec square x. So putting back the values, so minus cosec square x upon 2 root cot x. This is nothing but differentiation of root cot x with respect to x. This is the answer. Now differentiation of sec x and cosec x are done in the similar way, and so those are left to you. Let us do a new type of problem now. Now, in the next type, I am going to deal with the problem like sin raised to 4x, cos cube x. Here is any number. Here is a raised to any number is there. For example, 10 raised to 50x. Whatever the number you want to write, write it. No problem. Cot cube x, cot raised to 4x, etc. This type of the problems are our next type. For example, y equals to sin raised to 4x. So let y equals to sin x raised to 4, because sin raised to 10x, this can be written as sin x whole raised to 10. Sin raised to 9x can be written as sin x whole raised to 9. Tan cube x can be written as tan x whole raised to 3. This is the way we can write. So to find dy by dx of sin x raised to 4, what we have done? Y equals to sin x whole raised to 4. Now to apply the chain rule, step 1, what is there inside the bracket? Sin x. Therefore let sin x equals to u. Therefore problem becomes y equals to u raised to 4. Now differentiating both sides with respect to u. So dy by du equals to differentiation of u raised to 4 with respect to u equals to 4 u raised to 4 minus 1 equals to 4 u raised to 3. So dy by du equals to 4 u raised to 3. Call it as a equation number 1. After that, but u equals to sin x. So differentiating both sides with respect to x. Therefore, differentiating both sides with respect to x. Therefore, du by dx equals to differentiation of sin x with respect to x equals to cos x. Therefore, du by dx equals to cos x. Call it as a 2. Then what to do? You can multiply first result with the second result. In chain rule, you will get the multiple of results. You have to multiply all the results, then you will get the dy by dx. So dy by dx nothing but, what is the first result? Dy by du. And what is the second result? Du by dx. So dy by dx equals to dy by du, that is 4u cube multiplied by du by dx, that is cos x. So 4 cos x u raised to 3. What is u? U nothing but sin x. U nothing but sin x. Yes, u equals to sin x. So we put back the values. Dy by dx equals to 4 cos x and sin x whole raised to 3. That can be written as 4 cos x sin raised to 3x. This is a required result. So how to write it? We can write it like this: differentiation of sin raised to 4x with respect to x equals to 4 cos x sin cube x. Let us move to the next example. Next problem, y equals to, here cos raised to, suppose 5x. There can be any number. You're not to bother about what number is there. For every number, the procedure is same, provided here is a trigonometry and power is some number. So y equals to cos raised to 5x. That can be written as y equals to cos x and whole raised to 5. Then let u equals to cos x. The entire chain rule depend upon only 2 steps or 3 steps. I will tell you how the 3 steps also. If it is a composite function of 3 variables, 4 variables, then number of steps keep on increasing. Here are it is a composite function of 2. One is a u, another is a x. So now y equals to u raised to 5. So u is the first variable. So dy by du, differentiating both sides with respect to u, differentiation of u raised to 5 with respect to u equals to 5 u raised to 5 minus 1, 5 u raised to 4. So that is dy by du. And after that, but u equals to cos x. So differentiating both sides with respect to x. Differentiating both sides with respect to x. So we get du by dx equals to differentiation of cos x with respect to x equals to minus sin x. Let us call it as equation number 2, and it was equation 1. Now by chain rule, dy by dx equals to dy by du and du by dx. So that is equals to 5 u raised to 4 multiplied by minus sin x. So dy by dx, we'll put value the back. What is u? U is nothing but cos x. So putting back the value of u. So here is a cos x raised to 4 and here is a minus sin x. So that is equals to minus 5 sin x multiplied by cos raised to 4x. Therefore, differentiation of cos raised to 5x with respect to x is nothing but minus 5 sin x and cos raised to 4x. This is required result. Let us do one more problem. Suppose a problem is given to us where the number is not an integer. For example, here is a tan and power is 3 by 4, tan raised to 3 by 4x. So how to do dy by dx by using chain rule? Procedure is same, only we are afraid of 3 by 4. That is the only new thing has come, but procedure and everything is same, don't bother about. So first of all, what is given? We write given here y equals to tan raised to 3 by 4x. Then it can be written as usual tan x here and whole raised to 3 by 4. Steps are not changing. Let tan x equals to u. Therefore y equals to u raised to 3 by 4. Differentiating both side with respect to u. Then dy by du equals to differentiation of u raised to 3 by 4 with respect to u equals to 3 by 4 u raised to 3 by 4 minus 1 equals to 3 by 4 u raised to 3 minus 4 upon 4, 3 by 4 u raised to minus 1 by 4. Call it as a equation number 1. Now after that, what is u? But u equals to tan x. Steps are not changing, steps are same. Du by dx equals to derivative of tan x with respect to x. Derivative of tan x is nothing but sec square x. So du by dx equals to sec square x. Let us call it as equation number 2. Now after that dy by dx, dy by dx is nothing but multiplication of result 1 and result 2, that is dy by du, and second one is that du by dx, multiplying both of them. So dy by du is nothing but 3 upon 4 u raised to minus 1 by 4 into sec square x. Now here this is equals to 3 upon 4 and 1 upon u raised to 1 upon 4 into sec square x. That is equals to 3 upon 4, and this can be written as 1 upon 4th root of u. So writing 4 here and here sec square x. So this is equals to 3 sec square x upon 4 multiplied by 4th root of u. Now putting back the value of u nothing but tan x. Therefore 3 sec square x, this is dy by dx equals to 3 sec square x, 4, and here is a tan x and the 4th root of tan x. This is required answer. Next example, y equals to sec raised to 4x. Find dy by dx by chain rule. Now procedure is same. Let u equals to sec x, y equals to u raised to 4, dy by du equals to derivative of u raised to 4 with respect to u equals to 4 u 4 minus 1 4 u raised to 3. This is dy by du. Call it equation number 1. But u equals to sec x, differentiating both side with respect to x. So we get du by dx equals to differentiation of sec x with respect to x, that is equals to sec x multiplied by tan x. Call it equation 2. Now chain rule, by chain rule dy by dx equals to dy by du into du by dx. Dy by du nothing but 4 u cube and du by dx nothing but sec x multiplied by tan x. Therefore differentiation of sec raised to 4x with respect to x equals to 4. What is u? U is nothing but sec x, so it is a sec cube x multiplied by sec x tan x. So that is equals to 4 sec raised to 4 sec raised to x sec raised to 4x into tan x. This is required result. In next type, I am going to deal with problem like 1 upon 2x plus 3, 1 upon tan x, 1 upon cot x, 1 upon sec x, 1 upon cos x, or anything. 1 upon is there. So this type of problem let us do by using chain rule. Suppose we want to find out derivative of 1 upon 4x plus 5 with respect to x. So by using chain rule. So what we need to do? Before proceeding, I want to give you one recall. I want to tell you one formula. Derivative of 1 upon x. Derivative of 1 upon x is nothing but minus 1 upon x square. You just remember this formula. I repeat once again, derivative of 1 upon x is nothing but equals to minus 1 upon x square. So step number 1, let y equals to 1 upon 4x plus 5. Then let u equals to 4x plus 5. Then it becomes y equals to 1 upon u. Differentiating both sides with respect to u. Therefore, dy by du equals to differentiation of 1 upon u with respect to u. Derivative of 1 upon u nothing but minus 1 upon u square. Let us call it as equation number 1. But what is u? U nothing but 4x plus 5. So differentiating both sides with respect to x. So du by dx equals to differentiation of 4x plus 5 with respect to x equals to 4. Now dy by dx equals to dy by du into du by dx. Dy by du nothing but minus 1 upon u square and du by dx nothing but 4. Therefore, dy by dx equals to minus 4 upon u square. So dy by dx equals to minus 4 upon, what is u value? U value nothing but 4x plus 5. So putting that value back here, 4x plus 5 whole square. So dy by dx equals to, that is differentiation of 1 upon 4x plus 5 with respect to x equals to minus 4 upon 4x plus 5 whole square. This is the result of derivative of 1 upon 4x plus 5. Repeat, differentiation of 1 upon 4x plus 5 with respect to x equals to minus 4 upon 4x plus 5 whole square. Next example, y equals to 1 upon tan x. And we need to find dy by dx by using chain rule. Solution, what is given? Y equals to 1 upon tan x. Let tan x equals to u. Therefore, y equals to 1 upon u. Differentiating both sides with respect to u. dy by du equals to differentiation of 1 upon u with respect to u equals to minus 1 upon u square. dy by du, let us call it as equation number 1. But u equals to tan x du by dx, differentiating both sides with respect to x here. So du by dx equals to differentiation of tan x with respect to x. So du by dx equals to derivative of tan x nothing but sec square x. Let us call it as equation number 2. Now applying chain rule, dy by dx equals to dy by du and du by dx. Now minus 1 upon u square multiplied by tan multiplied by du by dx, answer is sec square x. So equals to minus 1 upon u square, that is putting back the value of u nothing but tan x. So dy by dx is equal to tan x whole square into sec square x. So dy by dx equals to minus sec square x upon tan square x. We can further simplify, but I am not simplifying. I just wanted to tell you how you will handle chain rule for 1 upon tan x. It can be simplified further. Therefore, differentiation of 1 upon tan x with respect to x equals to minus sec square x upon tan square x. This is required result. In next type of problem, I am going to do the problem like e raised to log x, e raised to sin x, e raised to 2x plus 3, or e raised to root x. So everything e raised to. So this type of problem I am going to do now. These are called exponential functions. So the chain rule for exponential function, only the formula is going to change, and working rule is same as we did in earlier case. We are going to do the same here. We are not going to change any step. The dy by du and du by dx will remain the same. Only the function has changed, and along with that the formula, the resulting formula will change. So let us have some examples on the basis of exponential rule. For an example, y equals to e raised to log x. Find dy by dx by using chain rule. Actually, it is not said in the questions of textbook to do it by chain rule. It is our decision that this problem can be done by using chain rule. So y equals to e raised to log x. How to do the derivative? The remaining same. So solution. In the solution we are having y equals to e raised to log x. Then let log x equals to u, y equals to e raised to u, and differentiating with respect to u. So dy by du equals to differentiation of e raised to u with respect to x. The derivative of e raised to u is e raised to u itself, and let us call it as equation number 1. But u equals to log x. If no base is there, the base e is there always. So differentiating both sides with respect to x. So we have the du by dx equals to differentiation of log x to the base e with respect to x. So differentiation of log x is nothing but to the base e, nothing but 1 upon x. So this is du by dx. Let us call it as equation number 1. Now applying chain rule, dy by dx equals to dy by du into du by dx. So dy by du nothing but e raised to u, and du by dx is nothing but 1 upon x. So dy by dx equals to dy by du into du by dx. So that is e raised to u multiplied by 1 upon x. So u nothing but log x to the base e multiplied by 1 upon x. So the final answer is e raised to log x multiplied by 1 upon x equals to e raised to log x upon x. Therefore dy by dx equals to e raised to log x upon x. Next example, y equals to e raised to 2x plus 3. Then how to find dy by dx? As usual, let 2x plus 3 equals to u. Therefore y equals to e raised to u, differentiating both sides with respect to u. Then dy by du equals to differentiation of e raised to u with respect to u equals to e raised to u. Call it as equation number 1. But u equals to 2x plus 3 differentiating with respect to x. So we have du by dx equals to differentiation of 2x plus 3 with respect to x equals to 2. So du by dx equals to 2. This is equation number 2. Now applying chain rule, dy by dx equals to dy by du into du by dx. Dy by du nothing but e raised to u, and du by dx is nothing but 2. Therefore dy by dx equals to 2 e raised to u. Putting back the value of u here. So what is the u value? U value nothing but 2x plus 3. So putting back the value here, this is the dy by dx equals to 2 into e raised to 2x plus 3. One more example where trigonometry is involved. Here algebra was involved, and now let us involve the trigonometry. Suppose y equals to e raised to sin x. Then how to find dy by dx? So solution, let sin x equals to u, then y equals to e raised to u, differentiating both sides with respect to u. So dy by du equals to differentiation of e raised to u with respect to u equals to derivative of e raised to u is e raised to u itself. So dy by du equals to equation number 1, but u equals to sin x differentiating with respect to x. So we have du by dx equals to derivative of sin x with respect to x. So du by dx equals to cos x. Derivative of sin x is cos x. Call it as equation number 2. Now dy by dx equals to, by chain rule, dy by dx equals to dy by du into du by dx. What you do now? You multiply both the results, and dy by dx equals to dy by du nothing but e raised to u, and du by dx nothing but cos x. Multiplying the result of 1 and 2, so we get dy by dx equals to e raised to u cos x, and putting back the value of u here, what is u equals to? What is u equals to? U equals to sin x. Therefore putting sin x here and cos x. So this is final answer. Dy by dx equals to e raised to sin x multiplied by, here is a cos x. This is required result. Now I will take another problem in which the e raised to quadratic is there, quadratic polynomial. Then how will you able to do the dy by dx? So let's see, e raised to a quadratic polynomial. Next example, y equals to e raised to x square plus 5x plus 6. Only the problem has changed, but the steps are remaining same. Let x square plus 5x plus 6 equals to u. Therefore y equals to e raised to u, differentiating both sides with respect to u, both sides with respect to u. Therefore dy by du equals to differentiation of e raised to u with respect to u equals to e raised to u. Dy by du equals to e raised to u. Let us call it as equation number 1. And after but what is u? U equals to x square plus 5x plus 6. Now differentiating with respect to x. So du by dx equals to differentiation of x square plus 5x plus 6 with respect to x. Derivative of x square is 2x and derivative of 5x is 5. and derivative of 6 is 0. Therefore, du by dx equals to 2x plus 5. Let us call it as equation number 2. Now by chain rule, dy by dx equals to dy by du and du by dx. Now multiplying both the results, first result is e raised to u and the second result is 2x plus 5. So dy by dx equals to e raised to u into 2x plus 5, that is putting back the value of u. What was u? U is nothing but x square plus 5x plus 6. So here x square plus 5x plus 6. We putting back the value of u here, and here is a 2x plus 5. Therefore, dy by dx equals to 2x plus 5 multiplied by e raised to x square plus 5x plus 6. Next example, suppose y equals to e raised to under root of sine 2x plus 5. You see, when you talk about chain rule, it can be interlinked two variables or interlinked three variables, four variables, n number of variables. So first of all, let under root of sine 2x plus 5 equals to u. Therefore, it becomes y equals to e raised to u. Then differentiating with respect to u. Therefore, dy by du equals to differentiation of e raised to u with respect to u equals to e raised to u. This is dy by du, equation number 1. But u equals to under root of sine 2x plus 5. Let sine 2x plus 5 equals to v. Therefore, u equals to under root of v. Then differentiating with respect to v both side. Then you get du by dv equals to differentiation of root v with respect to v equals to 1 upon 2 root v. Let us call it as equation number 2. Now after that, but v equals to sine 2x plus 5. Let 2x plus 5 equals to w. Therefore, v equals to sine w. Differentiating both sides with respect to w. So dv by dw equals to differentiation of sine w with respect to w equals to cos w. Let us call it as equation number 3. But w equals to 2x plus 5. So differentiating both side with respect to x. Therefore, dw upon dx equals to derivative of 2x plus 5. Derivative of 2x plus 5 with respect to x equals to 2. Let us call it as equation number 4. Since given question was composite function containing u, v, w, that is, it was triple composite function, and chain rule can be extended to the triple composite function as dy by dx equals to, what was the first result? First result was dy by du. What was the second result? That is a du by dv. And what was the third result? dv by dw. And what is the last result? dw by dx. That means we are multiplying all four results. Now dy by du e raised to u and du by dv 1 upon 2 root v and dv by dw nothing but cos w and dw by dx is nothing but 2. So we had all four result here, and so dv by dw was the cos w. And now what you're going to do, you are going to put back the values. And what is the u value? U value nothing but under root of sine 2x plus 5 and multiplied by 1 upon 2 root v, that is under root of v. What is the v? Sine 2x, sine of 2x plus 5 and cos w. What is the w here? W nothing but 2x plus 5. So you are going to write 2x plus 5 here, 2x plus 5 and 2x plus 5, and the last result is 2. Now writing properly, dy by dx equals to, first of all, 2 cos 2x, cos of 2x plus 5 into e raised to sine of 2x plus 5 divided by 2 under root of sine 2x plus 5. If any cancellation possible, do it. This 2 and 2 get cancelled. Therefore, finally we get dy by dx equals to cos of 2x plus 5 multiply to e raised to, write in the bracket, and e raised to sine 2x plus 5 and upon under root of sine of 2x plus 5. This is required result. Thus, chain rule can be extended to any number of composite function. It is a doubly composite function or triple composite function or n number of composite function can be easily extended. Let us do one more problem for better understanding. Next example, y equals to sine of log of root 5x log root 5x plus 6 to the base e. Step number 1, let u equals to log root 5x plus 6 to the base e. Therefore, y equals to sine u. dy by du equals to derivative of sine u with respect to u equals to cos u dy by du. Equation number 1. Next step, but u equals to log 5x plus 6 to the base e. Let root 5x plus 6 equals to v. Therefore, u equals to log v to the base e. Now differentiating with respect to v, so du by dv equals to 1 upon v. but v equals to root of 5x plus 6. Let 5x plus 6 equals to w, v equals to root w. So dv by dw equals to 1 upon 2 root w. But let us call it as this was the second equation, this is a third, but w equals to 5x plus 6, therefore dw by dx equals to 5, call it as a 4. Now we multiply all the rules, all the results, multiply all the results. Why? Because it is a composite function of u, v, w. Therefore first we done with respect to u, then we did with respect to v, then we did with respect to w. At the end x automatically comes. If x comes, then think that you are on the right track. So dy by du and du by dv multiplied by dv by dw and dw by dx. So dy by du nothing but cos u and du by dv nothing but 1 upon v and dv by w nothing but 1 upon 2 root w and 5. So what you do, dy by dx equals to 5 cos u upon v multiply by 2 root w. Therefore dy by dx equals to 5 cos of log under root of 5x plus 6 to the base e upon v. What is v? Root of 5x plus 6 and 2 root w, that is nothing but 5x plus 6. The root has come twice, therefore 5 cos of log root 5x plus 6 to the base e upon 2 of 5x plus 6. This is required result. dy by dx equals to 5 cos of log of root of 5x plus 6 to the base e upon 2 into 5x plus 6. Let us move to the other type of problems. Now y equals to 3 raised to under root of sin x. Let under root of sin x equals to u. Therefore y equals to 3 raised to u. dy by du, differentiating both sides with respect to u, dy by du equals to differentiation of 3 raised to u with respect to u equals to 3 raised to u log 3 to the base e. Let us call it as equation number 1. But u equals to root sin x. So let sin x equals to v. Then u equals to under root of v. Then differentiating both sides with respect to v. Therefore du by dv equals to derivative of sin root v with respect to v equals to 1 upon 2 root v. Call it as equation number 2. But v equals to sin x, dv by dx equals to derivative of sin x with respect to x equals to cos x. Let us call it as equation number 3. Now dy by dx equals to dy by du into du by dv and dv by dx. So dy by du nothing but 3 raised to u log 3 to the base e, and du by dv nothing but 1 upon 2 root v, and dv by dx nothing but cos x. Three raised to u log 3. Now arranging properly, putting back the values, u nothing but under root of sin x, dy by dx equals to 3 raised to under root of sin x log 3 to the base e multiplied by cos x divided by 2 root sin x. This is required result. Dy by dx equals to 3 raised to root sin x log 3 to the base e cos x upon 2 root sin x. Now we are going to talk about chain rule for inverse trigonometry. Example, y equals to tan inverse of 5x plus 6. Then step 1, let 5x plus 6 equals to u. Then y equals to tan inverse u, differentiating with respect to u. So dy by du equals to differentiation of tan inverse of u with respect to u equals to 1 upon 1 plus u square. But u equals to 5x plus 6, differentiating with respect to x, du by dx equals to differentiation of 5x plus 6 with respect to x equals to 5. Now dy by dx equals to dy by du into du by dx. So the first result is 1 upon 1 plus u square, that is 5x plus 6 whole square into 5. Therefore final answer dy by dx equals to 5 upon 1 plus 5x plus 6 whole square. If you wish, you can expand this 5x plus 6 whole square, but at present I don't feel need of expanding it. So this is the answer. Y equals to sine inverse of 2x plus 5. So let u equals to 2x plus 5, y equals to sine inverse u, dy by du equals to 1 upon under root of 1 minus u square. Call it as equation number 1, and u equals to 2x plus 5, du by dx equals to differentiation of 2x plus 5 with respect to x equals to 2. dy by dx equals to dy by du into du by dx. So that is equals to 1 upon under root of 1 minus 2x. What was the u? U was the 2x plus 5. So putting the 2x plus 5 here, 2x plus 5 whole square into 2. So therefore dy by dx equals to 2 upon under root of 1 minus 2x plus 5 whole square. This is required answer. So that's all about derivatives by chain rule. Actually, the chain rule is quite easy. It is not more than high school algebra. You might have seen that only 2 to 3 steps are there. Every time a new formula is coming, only the botheration is knowing the formula. Once you know the formula, it is not more than the high school algebra. So even though if you have more doubts on chain rule, please communicate with me on my email address provided in the description box. Also, remember to subscribe my channel and also share with your friends. Meet you again with another video, another time. Till then, wish you good luck. Bye bye. See you.